Imagine paying $30,000 for a GPU only to find it's 30% slower than the one next to it. In high-performance AI, you're playing a high-stakes game called the Silicon Lottery. Most assume identical instances deliver identical results. They don't. We're exposing hidden performance gaps, burning your budget, and stalling your training. We'll show you how to identify dud instances before they drain your ROI. We'll break down cost implications and give you strategies to get every teraflop you paid for. Stop gambling, let's look under the hood and find out how to win every time. Let's dive in.
All right, let's dive right into this explainer. We're looking at a high-stakes situation that's literally foundational to the whole AI boom going on right now. You know how it is. AI is just exploding, large language models are absolutely starved for compute, and companies are dropping massive amounts of cash every single day renting high-end cloud GPUs. But what if that massive compute power you're paying top dollar for isn't actually giving you what you paid for?
So, think one GPU is pretty much like another? Hey, it's a completely fair assumption. I mean, if you're paying a premium hourly rate for a specific NVIDIA chip, you'd absolutely expect it to perform exactly like the identical model sitting in the server rack right next to it, right? Well, as we're going to see, that baseline assumption, it's entirely wrong, and honestly, it could be costing you a ton of time and, more importantly, money.
Here's the real issue. We're operating under what you might call the GPU cloud illusion. The expectation across the industry is super straightforward. You pour your budget into renting these massive compute instances from major cloud providers, and boom, you get identical, predictable, uniform returns. You assume you're buying a perfectly standardized product. But the reality out there? It's way, way more unpredictable. Because when you pay for that cloud instance, you aren't actually buying a guaranteed speed. Actually, scratch that. You're buying a chance. Some startling research came out from the College of William and Mary, Jefferson Lab, and a company called Silicon Data, and it basically shatters this whole illusion. They found that when you spin up a cloud GPU, you're actually playing a game. You are playing what's known as the Silicon Lottery.
Now, what's really interesting about this concept is that the Silicon Lottery isn't just some catchy metaphor we made up. It's a fully documented historical phenomenon in the semiconductor world. The term strictly refers to measurable variations in the performance of identical chip models. In fact, University of Wisconsin researchers tied this exact issue to variations in GPU-dependent supercomputers back in 2022. But Silicon Data CEO Carmen Lee realized something pretty crucial. This lottery effect is going to be even more severe and way more costly for today's AI cloud customers.
And just look at the sheer scale of the Silicon Data investigation. This definitely wasn't just a fluke. They ran 6,800 benchmark instances across 3,500 randomly selected GPUs. That is a massive sample size. And they didn't just pick on one provider either. They analyzed 11 different cloud computing providers, testing 11 different NVIDIA GPU models. We're talking everything up to the highly advanced H200 SXM. This level of testing proves beyond a doubt that we're dealing with a widespread reality across the entire cloud rental market.
So how exactly do you measure this kind of invisible variance? Well, they used a specialized benchmark tool called SiliconMark. It's specifically designed to give you a snapshot of a GPU's ability to run large language models. To do this, it pushes the hardware to its absolute limits, testing two absolutely crucial metrics. First, 16-bit floating point computing performance, which, by the way, is measured in trillions of operations per second. And second, the GPU's internal memory bandwidth, measured in gigabytes per second. It basically pops the hood and shows us exactly what the hardware is truly capable of. And this brilliantly illustrates just how massive the performance gaps really are. Get this, the computing performance for the H100 PCIe GPUs varied by as much as 34.5%, and the memory bandwidth for the H200 SXM GPUs, a staggering 38% variance. Just put that into perspective for a second. Imagine paying full price for a top-tier server and getting nearly 40% less throughput than the person right next to you who's paying the exact same rate. No way, right? This isn't just some minor glitch. It's a direct hit to your ROI and your wallet.
So the really crucial point here is figuring out why this massive gap even exists in the first place. You might naturally point to the usual suspects, like differences in how the server farm cools the GPU, how the cloud operators configure their networking, or even just how much wear and tear the chip has already seen. And yeah, those absolutely matter. But Silicon Data's analysis revealed a massive twist. The actual culprit driving these wild performance swings? It's the inherent manufacturing variations in the chips themselves. Literally, the silicon is just baked differently at the factory level.
Which brings us to the harsh, dollars and cents consequence of this whole situation. Because of this inherent factory-level randomness, you are facing a very real financial risk. The researchers point out that there's a legitimate chance you could pay a huge premium to rent a newer, much more advanced GPU, only to pull an absolute dud in the silicon lottery. A dud that actually delivers worse performance than an older, cheaper chip. I mean, ouch.
All right, let's turn this into an actionable strategy. We aren't just here to admire the problem. We want to empower you to actually fix it. If you're renting these chips to train models or run intense computations, you need a way to beat the odds. You have to protect your investment and make absolutely sure you aren't gambling your budget away on slow silicon.
And Jason Kornick, the head of infrastructure at Silicon Data, offers a really definitive solution here. He says, and I quote, "The most practical approach is to benchmark the actual rental they receive. Running a benchmark tool allows them to compare their specific instance's performance against a broader corpus of data. So this is your action plan right here. The very minute you receive your rental instance, you need to run a test like Silicon Mark to verify its baseline speed before you start doing any of your real work."
Which leaves us with his final thought to chew on the next time you or your team logs into a cloud console to spin up a new environment. Are you actually getting the computing power you paid for, or did you just pull a losing ticket? By understanding the Silicon Lottery and proactively testing your instances, you can make sure you're getting exactly what you pay for. Thanks for joining me on this explainer. Stay curious, and hey, keep benchmarking.